Hello and welcome to today's panel discussion on laser soldering versus robotic soldering. The race is on at the moment between to automate the manual soldering process. So what are the alternatives? You can use laser soldering, or you can use the robotic soldering, which basically has the tip and the solder feed. I've got a distinguished panel here to discuss this. To my far right, we have Bill Rahn, who's a senior technician from Fancourt Industries representing Japan Unix. Next to him, we, of course, have Mike Goldberg from PROMATION, USA.
Good morning.
Good morning. And to my left, we have Denis Barbini from Laserssel.
Good morning.
Good morning, Denis. So I'll start off with you, Bill. Laser soldering was previously discounted because it used to burn the vias, used to burn the boards, but now they're using things like combined laser sources to bring the overall heat down. Does that make it then a credible option?
Absolutely it does. We offer options like parameter control, where we can actually attenuate the laser power depending upon the reading of the temperature at the solder joint. Mm-hmm. And that enables us to prevent a lot of burning. We can angle the solder head, we can vary the spot size, we can vary the spot shape. All of these different things we have as tools in our toolbox to prevent the anomalies that were experienced previously with laser soldering.
Right, okay. Sounds like a lot to set up though, you know, all these different options. But
those options are all programmable.
Right.
And once you get them set, it's a repeatable process. So.
Okay. Now, Mike, you used to have some experience in doing the robotic laser soldering process. You've taken the other option now, but I mean, what is your view on it?
Well, I think as you look at the timeline, the escalation of laser soldering, as Bill had mentioned, you know, the sensing technology has gotten much better, being able to monitor joint formation and temperature throughout the formation. I think that's going to continue to increase, as we also discuss and hope to discuss hot iron robotic soldering as well. I think many of the peripheral devices that surround the soldering technology in general are also continuing to improve as well.
Right, okay. You're obviously involved in the laser side as well, but what are your views on it, and what are the drawbacks of it?
So to address the issues of laser soldering and the temperature and the burning, our technique that we're looking at is very innovative in the sense that we are reducing the amount of energy that's being applied to a single point and dispersing all that energy over an area. We can do as large as 80 by 80 millimeter down to 600 by 900 micron. And by doing that, we don't burn, we can optimize the process for the time, the temperature, to not damage components, damage the board, and therefore give the end user a way to solve the problem.
So is that like a preheat process that you're doing on an area, and then using a more focused laser soldering application afterwards?
Well, we do have preheat as an option. However, this is more of taking a spot laser and putting it through our optics, and the optics allow it to be dispersed uniformly over an area. So we're not changing anything, we're just developing a process using area laser soldering. Very innovative technique.
Right, yeah, sounds it. Okay, Mike, there's many other factors that go into creating a good solder joint than simply applying heat. Is it possible to fully replace human interaction?
Well, I think when we look at soldering in a general scope, you know, the technology again has continued to improve over time. When we talk about the peripheral devices, such as what aids in process forgiveness through an automated process, you know, these devices, peripheral devices such as solder tip correction in a hot iron robotic setting, solder feed indexing, the accuracy of motors and ability to sense and detect minute differences is continuing to improve. When we look at, you know, Industry 4.0 and where we're heading, the ability for barcode scanning and selection, automation obviously on a conveyor throughout an assembly line and through this work cell, absolutely. I think as technology continues to improve, I think that there will be less and less requirement for manual labor. Sure.
Right. Okay. Bill, looking at the process, I mean, the soldering the joint is one thing, but do you want to, we have some sort of verification built into the machines to verify the formation of the joint and check that its electrical characteristics are correct and that sort of thing? Or is it okay just to have the soldering process and check it later on through an AOI or through the electrical testing systems you have at the end of the line?
Yes, normally with the process being repeatable enough, if your materials and tooling and programming and all of your formulas come together under the process control, then you should be able to run a sampling inspection program, either by electrical test, or you can possibly, with camera technology being integrated into the robot itself, visualize it as it's happening, much like an operator would now. And you asked the question previously about, can an operator truly be replaced? Well, I've done many, many hours of hand soldering myself, right. and knowing that my reaction to what I'm seeing formed in front of my eyes requires a level of intelligence that machines just don't have yet. Yep. But we do have AI coming, so incorporating that into the soldering process, I'm sure, will happen sometime soon.
Right. Well, I think that's some way off. But I mean, what do you think, Dennis? I mean, do you have verification, any kind of verification built into your soldering process, into the machine itself?
And that's a great answer, I think, that was given just now. Verification tools have to exist to make sure that you're getting the proper coalescence, the time to wet to things, center. That, that's still being developed, in my opinion. Being able to observe it using AOI is probably the best way, right now, more adequate in terms of development. For me, what I see is the industry is going into an environment where there's so many new applications that are very novel in terms of design, that typical processes like reflow and wave really are not suitable. So that's why you have robotic systems, you have our system that can take these esoteric niche type applications and turn that from a hand soldering process, or let's say a one-up, to a mass volume production automated. So you certainly can get the right quality, but also reduce the amount of workforce required to make that product.
Right, well I think one of the things I was getting at is that, with the smart factory coming on and this type of thing, they're wanting a lot more data coming off of these processes. So they want to have, you're replacing the hand soldering process with an automated process. You should be able to extract data from every point from that and be able to monitor for traceability and for quality control and that type of thing. Would you agree, Bill? Yeah? Okay. So, how easy is it to program and set up some of these automatic soldering systems? How do you go about it? How would you program your Unix system, for example?
Well, it's a camera teach to where we would know where the laser spot is on our screen by a crosshair, and then we could go in and put that laser spot where we want it to be, size it. The programming is very simple from an XY coordinate, and Z is a component as well. But it's very not difficult to do.
So how long does it take? Is it a quick process?
That's all depending upon how many solder points you have, how many different solder points you have to program in.
Right. So you have to do it point by point, or?
Yes.
Right.
Yes. There are applications where we can do CAD data, Gerber data, but it's just as quick usually for 10 to 20 points to go through and run the camera to teach.
Right. Mike, because you're using the solder feed and the iron separately, you have more to teach the system, do you? Or how easy is your system to teach?
So I think when we talk about the robotic soldering systems at play, herein lies about three, perhaps a few more, main teaching ingredients. One might be a point and teach system, such as what's traditional on tabletop hot iron robotic systems, very commonly seen in dispensing systems as well. We have PC-based vision teaching as well, and then we also kind of have the added Gerber input. Right now, most affordable on the market is perhaps the most basic, which is a point and teach system. It uses a very familiar motion control XYZ theta platform. in which an operator can point the robot to a location and then teach that information. Regarding time there and after, there are nuances varying between some manufacturers. I know, speaking with some of the systems we offer, we have expand, step, and repeat functions where you can take basic ingredients, let's call them, or recipes, and expand, step, and repeat those across the board for like solder joints or similar in an array, size and shape. And then, I think one thing we need to touch on as well is when perhaps robotic soldering may not make sense for your applications.
Right.
When the teaching becomes perhaps too long. So I think when we start talking about low volume, high value, there can be certainly a gray area there. We obviously want the repeatability of robotics, but we also understand there's a learning curve with whatever system is being offered, whether it's laser or hot iron, PC-based or point and teach, or perhaps where we'll be getting to, which is Gerber input or CAD import, definitely offers promise as well. But I think we can all attest that the applications we get are never the easy ones.
Right.
They usually are the challenging ones that require a little bit more.
Right. Right. I mean, so you're really more in the rework and repair area, doing these types of things, correct? Or are you going in talking about small production?
Well, I think we're really on the front end of everything. The actual manufacturing of the odd form component or the cable harness that can't necessarily be run through a traditional wave or selective process.
Right.
The temperature, resistant battery or HMP soldering that is just a challenge. So I think that there's definitely some great hope for manufacturers looking to automate, but I think we also have to have a very real conversation about when it does and when it doesn't make sense to automate. Everyone kind of wants the Mercedes-Benz, if you will, but sometimes making it practical is a different story.
Different story, yeah. Good point.
You drive
Dennis,
a Chevy, don't you?
how about teaching your laser cell system? How easy is it? And to Mike's point, what are your key applications for it? Where's your sweet spot for it?
Well, along the same lines, we get the hard stuff. Nothing easy for us. However, with the way we're applying the energy, it's really not so much teaching. We do have visual recognition, boards coming in, we know where we have to solder. But once we develop the process like you would do in a typical reflow mass convection oven, where you use thermocouples or quarter, you develop your process, you know your process window, and then you're done. So the process then is, at that point, it's all automated. If we have to do some applying of feed of wire, we can do that too, and that's another module. But once again, once we get that that's taught very very easily, the process is up and running in an hour or so,
Right.
or less.
So, Bill, obviously these systems are there to replace a number of humans that are there to do manual touch-up and that type of thing, and let them go off to do more interesting and more important jobs within the factory space. But how many people or many human operators does each machine replace?
Well, that's an interesting question because it's quite subjective. To talk about when you're doing the actual process, there really aren't any steps you can skip. I mean, it's essentially doing a contact process, for instance. You're breaking down the micro motions of hand soldering. So you have an amount you have to feed in order to create your heat bridge. You have an amount of time that you have to sit there on the joint before the joint is sufficiently preheated before you can start adding your fill solder. Sometimes you have to allow it to flow through the hole in order to add more solder. And that's where you're kind of taking what the operator does and breaking it all down so the machine gets it and it's repeatable. Right. So you can't really shortcut the process because your iron tip can't typically be hotter on an iron than it is for a hand soldering operation. Where you're going to save your time is in the consistency of the motion, the not being distracted by chatting with your neighbor, not being distracted by, if you allow cell phones on the floor, all of the different things that humans have distractions from. It keeps on turning them out. Okay. The other thing that's I think more of a tangible in all of it is your repeatability of the process. gets you to the point where you don't have as much inspection required at the end. Your product is of higher quality. So, like here's what it's totally all subjective.
Right.
Meaning that your product complexity again plays into it, and they never. I agree. They never throw the easy stuff at us.
Right. Well, and to your point earlier, Mike, I mean, I'm guessing they need to have a certain volume as well. It's not going to be useful for a high mix environment where you're having to change the program every so often. Is there a minimum number of boards that it's typically good for? I mean, obviously these machines could also work 24/7, but not everybody's running double shifts or triple shifts.
I think for every customer, the ultimate ROI is different. I think the gentleman from Unix happens to point out a lot of great things about ROI. It is subjective. It's relative to the cost of your system. It's relative to the cost of your labor. We know that there are certainly some things that humans inevitably excel at, as such as on-the-fly adjustments, being able to tweak how they're soldering and looking at the formation of a joint on the fly. Things that perhaps robotics will be able to do, but perhaps sometimes still out as we encroach upon the age of big data and AI. I think these things are definitely down the road. But I think, again, ROI, when you look at the repeatability, I'm working with a customer right now who we happen to save about 2 minutes per panel run, which when you start looking at the numbers and say, okay, well, sir, how many are you making of these per day? Oh, we make about 10,000. Well, that certainly starts to add up over time, and so the ROI can certainly add up. There can be an immediate ROI. Typically, I think we all try and look for the best ROI as possible for our clients. But again, something that I think is in the numbers and in the math for the customer to decide what technology, what price point makes sense for them to bring in-house and make it a feasible technology.
Right, okay. Dennis, would you agree with that? I mean, is there a minimum run that they should be doing before it makes sense?
I totally agree with the analysis that just mentioned. I also say that sometimes, depending upon the customer, they may do one or two things, but then they have a very high expectation for reliability, or they don't want to rework it anymore, so they got to throw it out. So they may be also investing. Their ROI is the quality, and that's also part of the equation as well.
All right, so we're fairly early into the journey for these new systems, automated systems coming in. Where do you think we're going to be? What's the roadmap in the next 5 years? Where are we for the next generation automated soldering systems? We'll start it with you, Dennis.
So I think traceability is paramount to anybody's analysis to optimize their factory. So I know that in every single machine, there's data that's being collected and then distributed. That's going to be key to understanding how to optimize the process. I see that in 5 years, there's going to be a lot more data to be tabulated and optimized, so that way it'll help us machine manufacturers to put the controls in place to say, for reflow soldering or just soldering in general, the time, the temperature, the result, we can optimize and give that AI and say, let's tweak it on the fly. That's why I see that happening.
Is it going to be AI or is it going to be deep machine learning?
I'm not an expert in that area, but it's definitely going to happen.
Okay. Mike, where do you think you're going to be 5 years' time with your systems?
Well, I'm not sure, although wishful thinking, I'm not sure within 5 years we may, by all means. I'm often told that I'm wrong. I think in 5 years' time, I'm not sure that we'll actually be at the age of big data and AI intelligence being incorporated on robots. But I think we are at an exciting time right now where we start to see collaborative robots playing a key role in cost reduction within the process or production of this product, such as fixture loading, fixture unloading, work cell loading, conveyorized barcode scanning abilities for traceability,
right.
Auto recipe selection. I think these will be some of the key features that manufacturers will be looking more and more to be in tune with as we move forward in the next 5 years.
So faster changeovers perhaps and maybe faster learning systems, that type of thing.
And perhaps even the mating of AGVs that I know we've seen quite a few around the show floor here today. AGVs docking with collaborative 6-axis arm robots, being able pick and place materials within a fixture on a conveyor belt that then indexes through a system.
Right.
Certainly we know that there's AOI, optical inspection, that can happen post-soldering. So it will be interesting to see how everything kind of mates together and who's going to be the first to pioneer it.
Absolutely. So Bill, last word to you. Where do you think it's going to be in 5 years? Or where would you like it to be?
That's a dangerous question. Where would I like to see it? I would like to see more automated controls and more thinking, like I mentioned before, to be able to make on-the-fly adjustments like a human would, but having the consistency of a robot to do its job. From a traceability standpoint, we already can do joint by joint parameter measurement of that joint as it's formed and log that. We've done it for customers on our lasers for the past couple of years.
Right.
You know, the collaborative robot loading and unloading of fixtures, not to boast on Fancourt, but we represent Unix, plus we're also a certified integrator for Universal Robots.
Okay.
So that's also in our toolkit.
Yeah.
But from a standpoint of laser and contact soldering, most certainly it would be the feedback to the control to make those on-fly adjustments.
Right.
Absolutely.
Right. Absolutely. Well, fascinating subject, you know, and I look forward to seeing how it develops over the next few years, and I want to thank you guys for joining me today. So there we go. So got Denis Barbini from Laserssel, Mike Goldberg from PROMATION, and of course Bill Rahn from Fancourt Industries. Thank you, and thank you for joining us.